C. Is the product formed in B optically active? Explain your answer. Okay, we will do the question 8 straight away. Okay, soalan 8 kita akan buat sepenuhnya. Let me make it smaller. Okay, so what's the question talking about? Of 3 isomer of C5H12. That is actually your introduction of organic chemistry. Okay, where we learn about isomer, possible isomer. So I will draw 3 of them. The C5H12, I think the very first one should be the 5 carbon straight chain, your pentane, I guess. Betul? So the second one is I make it smaller. So I make it shorter, basically. I make it to become a 2-methyl butane. Oops. 2-methyl butane. Check your hydrogen, check your carbon. Okay. And the last one, I think I will be making it into this. All right. Okay, quick question. Nama pakcik ni pentane. Can I have the another name of the second isomer? Anyone?
2-methyl butane.
Thank you. 2-methyl butane. And the last one, anyone?
2,2-dimethyl propane.
Thank you. Thank you, Amira. Thank you, Alif. 2,2-dimethyl propane. Okay, so that is my 3 isomer. Oops. Okay, that is my 3 isomer. So the question is asking for the B, which isomer form a single monochlorination product? Okay, untuk soalan macam ni, bila kamu dah jawab pakcik ni A, kamu nak jawab untuk B kan? Okay, sama ada kamu lukis balik, boleh, kamu boleh lukis balik, soalan tak minta nama tau, soalan tak minta nama, so tak payah buat nama pun tak payah, nama tu saya tanya untuk saya tanya je lah. So kalau nak senang, kamu boleh lukis balik ataupun you give a label. You label X, Y, Z pun boleh. Alright, you can label X, Y, Z and then di soalan B, kamu tak payah lukis balik lah. Tak payah lukis balik, tak payah bagi nama. Jawab je X, Y, Z pun boleh. With one condition, your X, Y, Z must be clearly labeled on your structure. Tak suka X, Y, Z, P, Q, R. Tak suka Roman 1, 2, 3. Any label. Just label that. Okay? So once you label them, you can choose. Okay, in the X, Y, Z, which one do you think form only single monochlorination product? Form only one product. X, Y, Z, which one?
Z.
Z. So, isomer Z. Yes, and I setuju. So, kenapa isomer Z? We talked about it yesterday, the Monday. The first thing that we will check when we want to see the product, how many product that we have is actually the class. Okay? So, in the X, you can see I have a primary, I have a secondary, I have a primary. Having a different class over here already result in at least 2 products because I have a primary, I have a secondary. Okay? So, dah out dah. Okay, dah out dah. Untuk Y for primary, I have a tertiary, I have a secondary, I have a primary. Sama. I have 3 different classes. I have a primary, secondary, tertiary. When you have 3 different classes, you definitely have 3 product already. Minimum. Betul. Ada lebih lagi. There is 4 product actually. Okay. So, ada lebih. Tak boleh. But here, I have a quaternary. I have a primary. Before I move on further, can I ask, when I say halogenation or when we say about free radical substitution on Monday, we talk about substituting halogen. Okay? But in quaternary carbon, can we put in a Br or a Cl over here? Why not? Why not?
Because we are substituting hydrogen.
Because we are substituting only hydrogen. Kita tak boleh ganti CH3. Kita hanya ganti hydrogen. And what Alif said is correct. And in the quaternary carbon over here, we don't have any hydrogen. Sebab tu quaternary carbon will never undergo halogenation because halogenation undergo free radical substitution over here. Alright. And in this free radical substitution, we are substituting. Kita akan substitute hydrogen with halogen with Br or Cl. Kita tak mengganti benda lain kecuali hydrogen. Faham? Therefore, it will then result in your Z isomer, you only have your primary. Okay? And in this case, all the primary, kalau kamu ganti mana-mana hydrogen dengan Cl, you realize that there is only one single product. Betul? So your isomer Z. Okay, so next, Mr. Lim question. Is the product formed in B optically active? Explain your answer. Optically active is actually your enantiomers. All right? Your enantiomers means your chilarity center, your chiral carbon. Okay? So look at this isomer Z. I redraw it so that you can see it clearly. Look at your isomer Z. Is this thing optically active? Do we have any chilarity center? No. Alright, kita tak ada. Betul, tak ada carbon yang pegang 4 ikatan dan 4 kumpulan yang berbeza. Tak ada. So over here, no. Not optically active. Alright, not optically active. Optically active. Okay, because no chilarity center, no chiral carbon, ataupun no chilarity center boleh, alright, and does not rotate in opposite direction of the plane polarization. Polarization. Okay? Tak, bukan optically active. Boleh? Pergi cari kat nota, di bawah nota enantiomers, in your topic Introduction of Organic Chemistry, under enantiomers, there is I think 2 sentences or probably 1 sentence about the thing optically active. Okay, go and read that out. And next question, extra question. The B, okay, the isomer Z that we choose is not optically active. Yes, saya setuju. But in the isomer that we have, XYZ, which one is optically active? Anyone? Ada yang optically active? Ada yang optically active? Tak ada, semua tak ada. Okay, tak ada satu pun optically active. Makes sense? Remember, I told you the Introduction of Organic Chemistry, they won't come out in the exam as 1 chapter. Betul? Dia takkan keluar sebagai 1 chapter. Tapi dia boleh keluar kat semua chapter. Okay? Example. Alright. So, next question. Next question. Exercise this.
Seven F.
Come again? Tak dengar sangat.
Seven F.
7F. Compare the color of the picture. Okay. This problem is sebab kamu tak buat amali lagi. In the lab by right, okay, if you are coming back later on, by right in the lab, you will be doing the experiment. Okay, you'll be doing the experiment for this halogen, your experiment 4 if I'm not mistaken. Kalau kamu buat amali untuk siapa yang SES, kamu dah pernah buat amali, then you should know. Okay, for this question, let's discuss everything except the mechanism. Okay. So for your question 7 over here, a student added in 1 ml of bromine gas into butane at room temperature on a bright sunny day. So bromine is the Br2. Butane is your CH3, CH2, CH2, CH3. Bright sunny day is your sunlight, UV. Betul? So it's basically the reaction that's going to happen. Now, A, state the type of reaction. Kalau soalan cakap state the type of reaction, jawapan dia akan jadi, what is your answer?
Free radical substitution reaction.
Free radical substitution reaction, correct Umi? Free radical substitution reaction. We talk about it last Monday. Banyak kali kita ulang benda tu. Free radical substitution. Yes. Saya nak tambah satu soalan. On top of this question, kalau soalan tanya, name the reaction. Nampak beza ya? I highlight a little for you. This one is state the type of reaction. This one is name the reaction. See the difference? And this answer will be halogenation. Nampak beza? Berhati-hati. Kalau soalan ada perkataan type of reaction, bila soalan ada perkataan type of reaction, your answer is those substitution, addition, elimination, rearrangement, that is your answer. Tapi kalau soalan cakap name the reaction, that particular reaction adalah apa? Apa yang berlaku? That is your halogenation, your oxidation, your dehydrohalogenation. Kita akan belajar banyak lagi lah along the way. Okay, that is the name. Alright, nitration, Feathercraft alkylation, ada benda-benda tu. Tapi jawapan kalau name the reaction, bukan substitution, bukan addition, bukan nama tu. See the difference? Berhati-hati. Okay, read very carefully what's the question. Beza satu perkataan je. Next, the question asks for, write the reaction equation. Okay, quite simple, the reaction equation. You already have the butane, CH3, CH2, CH2, CH3. Student akan selalu confuse, when is the time that I use the plus, when is the time that I put on top of the arrow. Betul? Kadang-kadang misal akan letak atas arrow, kadang-kadang saya akan letak bawah arrow, kadang-kadang saya akan guna tambah. Kalau soalan tu tak tanya what is the reaction, dia tak tanya specific, write the reaction equation. Kamu letak macam mana pun saya tak. Tapi kalau soalan tanya specific, write the reaction equation, guys, then benda yang kita guna, benda yang kita involve dalam reaction kena tambah. Benda yang involve kena tambah, but the condition, the inert solvent yang duduk hanya untuk melengkapkan situasi itu, duduk atas arrow atau bawah arrow. Okay? Alright, that is the one. And then your product, soalan tanya equation. So, produk semua kena ada. Major, minor, byproduct semua kena lengkap. So, for this question, I think you should have 2 product. By the way, ada masalah nak tentukan produk? Ada masalah? Oops. Duk tengok apa? Ada masalah nak tentukan produk? Let me know kalau ada. Okay? And then you should have 2 product over here because it's a butane. So, ganti 1 atau 4 akan sama. Ganti 2 atau 3 akan sama. Betul? Karbon pertama, karbon 4 akan sama. Karbon 2 atau 3 akan sama. And jangan lupa the byproduct HBr. When the question asks for equation, I'm expecting a complete equation. And saya nak ingatkan kalau equation bermakna tambah adalah tambah dengan benda yang akan involve dalam reaction kamu. Jangan letak atas arrow. Okay, tambah. Kita guna benda tu. Kita involvekan benda tu. Kalau benda yang tak involve, dan kita letak atas arrow atau bawah arrow. Boleh? Okay. Alright. Question? Is your line still very bad? I suppose yes, because you're so quiet. Okay, for the C. Draw and name the major product. So, do you still need to draw the major product? No. Tak payah lukis balik pun tak apa. Tapi pada equation B, kamu boleh label terus siapa major. Okay? I have the first product and the second product over here. Siapa adalah major? The first or the second?
Second.
The second. Why?
Highest class.
Higher class. Okay, we will see at the explanation later. So, your C over here, draw and name. Perlu lukis balik? Tak payah. Sebab apa tak payah? Kamu dah lukis. Kamu dah lukis dan kamu dah label major. Lukis dan label terus kat bahagian B, kamu dah dapat dah markah untuk draw the major product. Cuma kat sini kita hanya perlu name the major product. So how do I name? Nama dia akan jadi 2-bromo. Kita tak belajar lagi, so saya bagilah. Cuma kita akan jumpa benda ni nanti di haloalkane. Bromo adalah BR. 1, 2, 3, 4. Kita kira dari kiri supaya bromo dapat nombor terendah. Okay, sebab tu kita kira dari kiri. So 2-bromo-butane, itulah nama dia. And one more mark over here. The question asks you to draw and name. You have draw them already. And you have named them. Dengan syarat saya nampak meja. Dengan syarat saya nampak meja. Of course, kalau kamu tanya saya, teacher, kalau saya lukis balik boleh? Tak ada masalah, lukis balik lagi elok. Cuma saya nak ajar cara senang lah ni. Supaya kamu jimat masa sikit. Okay? Alright. For D, I won't show you because it's the mechanism that I think we do yesterday. Exactly the same. Betul? Cuma saya nak inform sahaja. If the question say, write the mechanism for the formation of product. Okay? They didn't say major or minor, and they only say the mechanism for the formation of product, and you have more than one product. You have 2, 3, 4 product. Ada banyak product. So kalau ada banyak product, which one do I draw for? Which mechanism do I show? Kita tetap akan tunjuk untuk yang major. Kita tetap akan tunjuk untuk yang major. Soalan cakap ke, soalan tak cakap, kita tetap akan tunjuk untuk yang major. Faham? Okay? Ingat ya. Kalau ada lebih daripada satu produk, soalan minta mekanisme, tapi dia tak bagi tahu dia nak mekanisme siapa. Kalau dia cakap minor, dia cakap A, B, C, hang ikutlah yang dia cakap tu. Kalau dia tak cakap, straight away major. Okay? And D, that's it. We want to go for E. E and F is the one that I want to discuss actually. Okay? E. Question asks you to explain the formation of the major product. So basically the question asking you why that is the major product. Okay, soalan tanya, kenapa yang tu adalah major product? And anybody want to try your sentence? Anybody want to try? Kedekut ke lampu ni? Tak ada siapa? Because line is very bad, I suppose. No? Line teruk kot, bukan tak ada kot. Positif je misal. Explain, okay. This question, no matter in what chapter after this, kalau ada isu major minor product, antara soalan favorite will be explain why that is the major product. And your answer will always relate to the stability of intermediate. Jangan jawab kat saya sebab dia higher class. Always relate to stability of intermediate. Alright? Intermediate kita ada apa? Remember your free radical? Alright? Remember your carbocation? Okay. Remember your carbon ion? Of course, saya kata yang ni major sebab kamu tengok kelas secondary. Cepat, betul. Tapi reason dia yang betul-betul kenapa dia adalah major, sebab sebelum dia jadi produk sayang, sebelum dia jadi produk, pacit ni jadi free radical. Sebelum dia jadi produk, pacit ni jadi free radical. Okay? So pacit ni adalah secondary free radical. Pacit ni adalah primary free radical. Dan antara primary free radical dengan secondary free radical, your intermediate over here is secondary more stable. That's why secondary akan wujud banyak. So whenever the question asks you about the major product, kenapa yang tu adalah major product, you must always relate to the stability of intermediate. Okay? So draw this thing. Draw this thing. You draw this, you label this. Okay, that is just E lah, kamu lukis. And bagi tahu satu je, bagi tahu statement, the secondary free radical, form in butane, is a butane ya. Masih menjawab soalan, yang ni depends pada soalan lah. The secondary free radical butane is more stable than primary free radical butane. And the only thing that change, all right, in the exam later on, akan depends on what type is the intermediate. Kalau free radical lah. Kalau carbocation lah. Kalau kelas dia berbeza, tertiary more stable than secondary, yes. Tertiary more stable than primary, yes. Okay, but always remember, jangan bagi tahu, oh, because it's a secondary. Secondary what? Secondary carbon? No. Secondary what? Secondary of the intermediate. Free radical. In this case, free radical. Boleh? Okay, always. Last but not least. Soalan F. Compare the color of mixture under sunlight and in the dark. Okay. So I have this equation right now. And we know that this thing is extremely, how to say? This thing is extremely sensitive to sunlight. Okay, we talk about it on Monday, where in our step 1, you must have your sunlight. Okay, you must have your sunlight. Baru reaction tu akan berlaku, betul? Step 1, your chain initiation berlaku. Your BR2, alright, in your chain initiation berlaku sebab ada UV, so dia serap tenaga, so BR putus, BR jadi free radical. Betul? Bayangkan kalau step ni tak wujud. Bayangkan kalau UV tak wujud, UV tak ada. UV hilang, saya letak dia dalam bilik gelap. Jadi tak step ni? Tak jadi, dia tak akan putus. Dia tak akan putus. Betul? So, read the question again. The question actually asking for two things, if you realize. We are looking for the color of the mixture. And we are looking for the explanation. The color of the mixture, in other words, the question asking for observation. Okay? And what is observation? Observation is what you can see with your eyes. So, kamu lukis, kamu tak payah tulis sentence panjang-panjang. Label je sunlight. Label je in the dark. Okay? Write the observation. Sunlight. Anybody know the original color of bromine? Yang SES mesti dah pernah buat. The original color of bromine. Apa line teruk kan? Apa tak nak layan aku? Kan apa dah penat, lapar tak makan lagi. Oh my god. Yes, Liv.
Sunlight dia colorless.
Colorless. Straight away colorless. I repeat my question, Liv. What is the original color of bromine? Sorry, Lim? Lim say?
Brown
Lagi?
color
Just
tu
too light then
colorless.
I heard the wrong thing.
Okay, brown color. Selain brown color, lagi tepat?
Yellowish.
Yellowish, Umi, you are going to die. That is bromine water. Lagi?
Reddish brown.
Thank you, Alif. Reddish brown. The original color of BR2, the BR2 is actually reddish brown. The original color adalah reddish brown. So, fikirlah, sayang, sekarang saya ada UV. Bila kita ada UV, reaction berlaku. Reaction berlaku means the BR2 will break apart and substitute into the hydrogen. Okay? So, kalau dia dah break apart and substitute into the hydrogen, ada tak lagi BR2? Tak ada lah. Betul? So, what happened to the reddish brown color? Alif, saya tak nak jawapan turn to color. Saya nak jawapan dari apa jadi apa. So, in the sunlight, the reddish brown, bagi tahu, the original color, reddish brown of BR2, decolorized. Kalau tak nak guna perkataan decolorized, the decolorized boleh ganti dengan reddish brown color of bromine turn colorless pun boleh. Tapi kat depan mesti kena ada reddish brown of bromine. Okay? And that is in the sunlight. What happen if you are in the dark? Kalau in the dark, tak ada UV, reaction ni tak berlaku. Bila reaction ni tak berlaku, free radical semua tak ada. So, saya ada BR2 dan BR2 saya kekal. Betul? BR2 saya kekal. So, what happened to the color? Reddish brown of bromine of BR2 remain unchanged. Saya tak nak jawapan no change untuk manusia-manusia PDT, saya tak nak jawapan no change. Untuk siapa yang dah buat, I don't want no change. Okay. Observation is always the things that you see with your eyes. So you need to tell me the color that you see with your eyes. Okay. So one, reddish brown color of bromine decolorized. One more, reddish brown color of bromine remain unchanged. That is the observation. Tak explain lagi. Alright, that is only the observation. So now the question is why? Remember, we have UV. UV is the most important thing right now. So, just bagi tahu lah function of UV. What is the function of UV? Why in the sunlight reddish brown will decolorize? Bagi tahu apa yang UV buat. Just mention, because with the presence of sunlight, apa UV buat? Apa yang sunlight buat? Anybody?
Provide energy for homolytic cleavage to form free radical.
Okay. Thank you, Umi. Pandai baca jawapan saya. If you look at my sentence consists of 3 different parts. Provide energy first, homolytic cleavage second, product dia apa? Free radical. Saya tak nak apa-apa yang tertinggal. Okay? Whenever we are comparing sunlight and in the dark, soalan akan tanya 2 benda je. Observation, reason. So the observation is what we give to you. The second reason is definitely the function of UV. Okay? Provide energy. For homolytic cleavage. Seperti yang Umi cakap, for homolytic cleavage. To produce free radical. This is the reason. Okay? This is the reason. Make sense? Yeah? Okay. I'm looking forward for you to come back to the college, and then next 2 weeks, I think you'll be doing your practical test. And hopefully that you will still do this experiment. It's a very good experiment because organic experiment is very important. Organic experiment involve all the qualitative experiment. All right? So doakan supaya kamu boleh buat so that you can see the color changes right in front of your eyes. Kamu boleh nampak what happened to the reddish brown. Kamu boleh nampak what happened to the purple color. Kamu boleh nampak what happened to the orange color or whatsoever in the other experiment. Okay? So, that is your question 7. I think we are done. Any other question? Semua boleh buat? Any other question?
12.
12. 2,2-dimethyl propane react with bromine in the presence of UV light. Okay. And then name the type of reaction, show a complete reaction, mechanism for above. Okay, that's it. Oh, sorry, 12 kan? Ni 11. Miss on 12 pun tak reti. Sorry. 12. Bromine solution in dichloromethane. Bromine solution, Br2, in dichloromethane, that is your inert solvent, is added to hexane. Hexane adalah 6 carbon straight chain. Okay. And exposed under sunlight ada UV. State the observation and write the equation for the reaction above. Then write a complete mechanism for one of the major product. Okay. So, first and foremost, dia ada banyak product. Let's see how many product you have. I have state the observation. Observation dulu. What would be the observation right now? Again. Baru bincang tadi. Anyone? Complete sentence? Line teruk kot. Reddish brown of bromine of Br2 decolorize. Okay, decolorize. And the equation, quite simple. Can I ask how many product do you have? How many product do you produce? You dapat berapa?
2.
2. Anybody else?
3.
3.
Eh.
3. Lagi? Tak ada. Let's see. The first one, I think is the primary lah. Mana-mana satu primary. Sebab mana-mana satu primary will give you bromohexane. 1 bromohexane. Betul? So, I substitute any of the primary. Buang satu hydrogen, ganti dengan Br. Make sure satu hydrogen keluar. Okay, baru boleh ganti. So, salin betul-betul hydrogen-hydrogen yang ada. Kira betul-betul hydrogen-hydrogen yang tinggal. 5, 6. Tu yang pertama. Yang kedua, saya ada banyak gila secondary. Saya ada banyak secondary. Secondary. My question, is all this secondary the same? Is all this secondary the same? I don't know whether you realize or not, kalau teacher letak nombor of the position, mungkin kamu akan nampak sikit. That is first, second, third, fourth, fifth, sixth carbon. Betul? Alright, betul kan? 1, 2, 3, 4, 5, 6. Sama juga dengan kalau teacher letak nombor dari 1 kat sini. 1, 2, 3, 4, 5, 6. See something? See something? So, karbon nombor 2 akan sama sebenarnya dengan karbon nombor 5 ni. Betul? Sebab kamu ganti kat mana-mana 2 atau 5 ni, dia akan hasilkan 2 bromopentane. 2 bromohexane. Right? So, saya pun gantilah. I have CH3, karbon kedua. CH sahaja sebab ganti dengan Br. CH2, CH3. Sorry. CH2, 1, 2, 3, 4, 5, 6. Okay. One more. Realize or not, 3 dengan 4, 3 dengan 4. So, karbon ni dengan karbon ni, kamu ganti mana-mana pun, dia akan jadi karbon nombor 3. Betul? Dia akan jadi 3 bromohexane. Agree? That's why untuk siapa yang dapat 2 produk, that's why kawan kamu kata 3, the third one is actually the another secondary tetapi position yang berbeza. That is my Br. Alright. And it's different. 1 bromo, 2 bromo, 3 bromo. And of course, the HBr. Don't forget. Okay. Write the complete mechanism for one of the major product. Kenapa soalan guna perkataan one of the major product? How many major product do we have?
2.
2. Kenapa? And which one?
Second and third.
Thank you, Ifan. Second and third. Sebab dua-dua adalah secondary. Pakcik ni primary. So, in this case, dua-dua kita label major. Okay? Dua-dua kita label major. Perlu saya tunjuk mekanisme untuk yang ni? Perlu tak perlu? Sebab kalau boleh saya nak tunjuk satu mekanisme nanti untuk yang cyclic. Sebab saya tak pernah tunjuk untuk yang cyclic kan? Alright, so yang ni samalah. So pilih mana-mana, buat mekanisme sama je. Okay. Talking about mechanism, let's try a cyclic. Tak ada. I'll give a random question. Cyclo apa nak?
Propane.
Cyclopropane. Cita-cita hang sangat tak tinggi. Cyclopropane je. Kita buat yang ni sikit lah. CH3 plus Br2. A quick one. Produk saya tak bincang dah. Kenapa produk dia ada banyak. Saya nak tunjuk pada mekanisme sahaja. Kamu tengok je lah produk dia. You have your CH3. You have your Br. And then you have one more CH3. Tekan Br duduk sini plus HBr. Okay. So the major product is this one. Yang ni semua saya tak nak cerita dah. Saya nak tunjuk untuk mechanism sahaja. So chain initiation. First step. Saya tak sure saya insist ke tak last week, last Monday. You have your BR. For the step 1, saya takut saya tertinggal. So saya nak insist sekali lagi. Make sure ada UV. Tak ada UV, reaction tu tak jadi. Tak ada UV, step ni takkan jadi. So chain initiation ada UV, half-headed arrow daripada BR kepada BR. Okay, half-headed arrow. Next, kamu akan hasilkan BR dot, kamu tambah BR dot. That is your step 1. Okay. Next, moving into your step 2. Okay, moving into your step 2. Your step 2 adalah chain propagation. So, kamu pun label lah, chain propagation. So, your chain propagation will be taking the free radical of the Br that you form in your step 1. Kamu ambil dia. Kamu akan react dengan the methyl cyclopropane. Dan saya nak tunjuk untuk major product. So, tunjuk hidrogen yang major tersebut. Okay. Dah. And then, the Br akan main tengah. Hidrogen akan bergerak kat dia. So, hidrogen akan ambil elektron dululah pergi kat hidrogen. Baru hidrogen boleh bergerak kat dia. So, one more akan pergi menuju ke carbon. Menuju ke carbon. See that? Alright. And then, you will produce your HBr byproduct. And look at your free radical, guys. Look at your free radical. Free radical duduk kat mana? Free radical duduk kat carbon yang kehilangan hidrogen tadi. Nampak? Tak perlu expand, tak perlu tunjuk carbon tu. Bagi titik tu duduk kat situ. That's it. And then we are going to use this free radical that you form over here. Take that free radical. And it will then react with the Br2 that is still neutral. Okay. So, your free radical, okay, ada orang tanya, teacher tunjuk 2 arrow dari ikatan ke H, dari H ke tengah. Tapi dalam nota teacher tunjuk terus daripada ikatan jumpa kat tengah. Yang mana satu betul? Dua betul. Mana yang kamu senang faham, mana yang kamu ingat storyline. Okay. So, yang ni boleh tarik terus. Kalau kamu kata, teacher saya nak tarik terus, banyak sangat arrow, pening. Okay, nak tarik terus. Boleh, tak ada masalah. Tapi kalau tarik terus, tak boleh tarik daripada BR. Kena tarik daripada ikatan. Okay. Must be from the bond. Yang ni pun sama, from the bond to the BR. And then, you will be forming what? You will be forming your product, CH3. Free radical tu dah jumpa ikatan baru dengan Br. And you're forming a Br free radical. Nampak? Happy? So, don't be so nervous when you come across cyclic. It's the same. Tak payah expand pun. It's the same. Nampak? Letak je titik pada carbon yang betul dan you'll be safe. Alright? Next, we are going into your termination. So your step 3 over here is your chain termination. Okay. So your step 3 chain termination over here, what will happen is, first and foremost, definitely BR. Tak ada issue ah. Betul. So arrow, make sure it's going in from the dot. From the dot going in. Jumpa? You got your BR form. BR2 form, sorry. Yang ni yang saya nak tunjuk. CH3, free radical, react with another cyclopropane CH3, free radical. So, datang daripada ni, datang daripada ni. Alright, datang daripada titik lah. Dua-dua datang daripada titik. Sayang, ingat tak saya cakap tak payah susun balik? Kan? And then you have another CH3. Yang pegang CH3. Dua carbon ni kan? Kan? That's it. Okay? Tak payah susun balik nak bagi elok. Tak payah saya nak jawapan betul. Saya bukan nak jawapan yang elok susun pun. That's it. Okay? Dah? Kalau ada yang kata, teacher pun susun balik ni. Saya tak nak susun balik langsung. Saya nak lukis je dua tu. Tak ada masalah. Boleh? Okay? I don't want any rearrangement, please. Because the more you arrange, the more kamu pening, the more kamu pening, the more kamu salah. So tak payah. Saya nak kamu salin balik sahaja. So, same thing over here. Last but not least, this is quite a simple one. And you will get another of your major product where you will produce CH3Br. Any problem with the mechanism? Umi say no problem. The first thing that you'll see me next week, mechanism. On the board. Any question that I want. Satu arrow salah, satu kelas ketuk ketampi. Okay? Any question? No? Okay. Make sure you can do. And student always struggle with the cyclic, rasa cyclic tu lain. Sama je. It doesn't really matter. The cyclic, cyclopropane ke. Hampa cita-cita tak tinggi lah weh. When I ask you open question and you give me cyclopropane. Lepas tu hampa kata, alah Miss Wong selalu bincang soalan senang. Saya tanya nak guna apa? Hang bagi cyclopropane yang carbon paling kurang. Hampa cita-cita rendah sungguh lah. Okay. Never mind. So do it. Make sure the titik duduk kat tempat betul. Itu je. Okay. The titik duduk kat tempat betul. Alright. Any other question? Ada soalan yang tak boleh buat lagi? Is line really that bad? Kita tengok yang ni sikit. I don't know. Sorry. Anis?
2.
Okay, boleh. 2. Hexane, colorless liquid. Liquid hexane is lighted up in evaporating dish, different lab. More soot is observed when hexane in lab X compared to lab Y. Okay. Saya ada 2 bilik. 1 bilik X, lab X. 1 bilik lab Y. Dua-dua orang ada hexane. The compound is the same. Okay. But more soot is in X. But when I burn it up, I realize that I produce more soot in the lab X and I produce less soot in the lab Y. By the way, do you know what is soot? Jelaga. Thank you, jelaga. Alah, bila hang bakar-bakar tu, lepas tu dapat keluar asap hitam tu jelaga. Okay? Kadang-kadang bila kamu bakar api besar, betul tak? Bila kamu bakar api besar, kamu tak nampak asap hitam kan? Sebab tu oksigen cukup. Tapi kadang-kadang bila kamu bakar, asap je keluar banyak. Betul? Sebab oksigen tak cukup. So, kamu kena buka-buka ruang tu supaya bagi oksigen masuk. Nampak? Oh, saya dah bocor dah soalan saya. Jawapan saya. So, over here, when you have the same thing, exact same thing that burn in 2 different labs, and then they give you different observation. Obviously, what caused the changes is the surrounding. Betul? It's never about the hexane. Why? Because hexane is the same. I only put into different room. So the observation is definitely affected by the surrounding. Okay? And we are talking about burning. We are talking about combustion. So dua-dua kita bakar, combustion. So in your mind, you should straight away come into 2 types of combustion. The complete and the incomplete. Agree? So the complete combustion and the incomplete combustion. My question, which one will produce more soot? The lab X adalah complete atau incomplete?
Incomplete.
Incomplete. Alright. Bila kamu bakar, kamu pernah balik kampung tengok orang-orang ataupun kalau taman rumah kamu tu ada pakcik yang suka bakar rumput. Okay, daun kering. Kadang-kadang bakar daun kering, dia akan jadi laju je kalau kamu nampak api terbuka, bla 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 tu kan. Yang tu sat lah. Lepas tu dia pun tak berasap sangat. Betul? Dia cepat je. Tapi bila bakar daun yang dia letak bertimbun, lepas tu dia bakar kat tengah-tengah, keluar asap tu. Kenapa dia hanya keluar asap? Sebab oksigen tak cukup. Alright? So, in lab X, what happen when you produce more soot? Whenever we talk about combustion, dia ada 3 keyword je. The type of combustion, alright? The oxygen supply, the product. Tu je saya nak. So, in lab X, incomplete combustion form. Incomplete combustion. Kenapa? Due to the limited supply of oxygen. Oxygen gas. Sorry. Oxygen gas, tak nak oxygen je. Oxygen gas. Due to the limited supply of oxygen gas. Saya pun sangat lapar. The whole morning saya kelas. Supply. Okay. So, and produce carbon monoxide gas. Kena bagi tahu produk. Okay. Boleh? So, whenever dia adalah cerita pasal combustion, bagi tahu jenis combustion, bagi tahu keadaan oksigen, how do we sell supply? Supply. Why I look stupid today? I don't know, eh? Oh my God. All right. Anyway, yeah, back to that. 3 things, the type, the oxygen, and the product. Kena ada. Same thing over here. Why you have less soot? Simple. Complete combustion. All right, in lab, why complete combustion? Due to the presence of excess oxygen gas. Okay, and produce, bagi tahu produk, and produce carbon dioxide gas. Habis. Whenever dia bakar benda yang sama, dia mesti bakar benda yang sama dalam 2 keadaan yang berbeza, and dia kata compare. Cerita dia mesti adalah complete atau incomplete. And whenever cerita complete atau incomplete, dia mesti kena ada 3 keyword. The type, the oxygen, the product. Okay? Alright? Alang-alang soalan 2 duduk kat atas, kita tengok soalan 3 sikit. Question 3, I have test tube W. That is my W. That is my V. One is filled with water. One is filled with ether. Write down the observation when 2 ml of liquid pentane is added. I add in pentane. Soalan pun sama. There is 2 questions if you read very carefully. The question asks for observation. The question asks for explanation. So ada 2 soalan tau, actually. So the first question, observation. What do you think the observation for this case? Soalan pertama.
Solubility. Solubility.
Solubility. Definitely about solubility because you put the same thing into water and ether. Alright? Observation is always the things that you see with your eyes. Imagine kamu ada test tube depan kamu ada air, kamu ada pentane. Soalan saya yang pertama, pentane larut tak dalam air?
Tak.
Tak. Okay. Bila benda tu tak larut, pernah main minyak dengan air? Bila benda tu tak larut, mata kamu akan nampak apa?
2 layer.
Thank you. 2-layer solution form. mata kamu nampak apa? Mata kamu akan nampak 2 layers solution form. Saya kesian gila kat Ampa sebab Ampa tak masuk lab dan Ampa tak buat benda ni. Padahal semua benda ni kita buat kat lab dan kamu akan nampak. Alright. So, observation is 2 layer solution form. Okay. And over here, kita habiskan yang ni dululah. So, next question. Why? I told you already the answer last Monday. Whenever in water and whenever dia tak larut, can I know why?
Because unable to form hydrogen bond with water molecule.
Umi said because unable, saya repeat ayat Umi ya, because unable to form hydrogen bond with water molecule. Soalan saya, siapa yang unable to form tu? Pentane tak jawab soalan. Alright? Because pentane, jawab soalan ya. Soalan kalau tak guna pentane, hang tukarlah ikut soalan. Because pentane cannot form hydrogen bond with water molecule. And the other. Nampak? Senang? Okay. Kalau senang, let's move on a little. What happened when you have your pentane and ether? What do you think the observation will be? Soalan pertama, definitely. Alif dah cakap dia adalah soalan solubility. So the first question that you should ask yourself, pentane dengan ether, larut atau tak larut?
Larut.
Larut Kalau larut, apa jadi pada observation kamu? Kalau benda tu larut.
Dia tak ada 2 layer. Dia dissolve macam satu solution.
So, ayat dia? Ayat yang tak berapa bijak tu kamu boleh tulis lah. 1 layer solution form. Alright, ni ayat tak berapa bijak ah. Boleh tak salah pun. Tapi, saya rasa yang lagi bijak adalah, remember this word? Homogeneous. Bila benda tu larut dan jadi sekata, bila benda tu larut, when the things dissolve and it become the same thing, the one whole thing, alright, we call it homogeneous, okay? Homogeneous solution form. I think this will sound better. Sound more scientific, okay? Alright, kalau benda tu larut, bermakna kita akan kata dia homogeneous solution form. And the reason. Yang ni saya tak bincang hari tu, so saya nak bincang hari ni. Why? Because pentane is a non-polar molecule. Okay? Pentane adalah non-polar molecule. Semua adalah carbon dengan hydrogen sahaja. Because pentane is a non-polar molecule. So, bila dia non-polar molecule, ether is also a non-polar molecule. Okay? Because pentane is a non-polar molecule which will form van der Waals forces. Spelling van der Waals forces yang betul. Sorry. Which will form van der Waals forces with ether. Okay. Ether pun adalah non-polar molecule. Dua-dua adalah non-polar. So, bila dua-dua non-polar, diorang boleh terikat antara satu sama lain. Bila dia boleh terikat ataupun dia boleh attracted to each other, they will be having a forces. What is the force of attraction? Kalau dengan water adalah hydrogen bond. Kalau dengan non-polar molecule, van der Waals forces. Okay? So, pentane is a non-polar. Ether is also a non-polar. They can dissolve into each other because they can form van der Waals forces. Nampak? Simple. Alright? Simple. Any other question? Soalan lain? Tak ada? Last, can we look at the thing? Before we end today. I have chlorination, means I'm using Cl2, of 2-methyl propane, yield multitude of product. Bahasa je weh. Multitude tu a few. Okay? Whereas the bromination of the 2-methylpropane, the same thing, but bromine, produce mainly only one product. Mainly bermakna majority, satu. Nampak? Kita lukis sikit 2-methylpropane. So, my 2-methylpropane shall look something like this. Okay? And when I react the 2-methylpropane with Cl2 UV, when I react this with my Cl2 UV, I shall produce this product. Correct me if I'm wrong. Saya pun jawab terus je. So, kamu akan dapat this one. Setuju? For me, yes. All right. Okay. And I'm going to repeat the exact same thing, but with Br. I'm going to repeat the whole thing with Br. And you realize that produk pun akan sama. Tetapi position tu akan berubah. Kalau tadi adalah Cl, position pula berubah. Position sama tapi benda tu berubah. Kalau tadi adalah Cl, sekarang saya ganti dengan Br. But it will be exactly the same. So, masing-masing ada dua produk. Okay, masing-masing ada dua produk atas kertas. And then, this one is the Br second. And if you don't mind, read the question again. The question stated that the chlorination will produce a few product, yield multitude product. Yes, saya ada dua. Betul lah? Betul. Bromination produce mainly only one product. Remember the story of major minor? Where in this case, kita ada major. Saya malas nak cerita dah kenapa ada major. You should know already that is your major. And if you remember, talking about the major minor, I told you that bila chlorination, dia tak ada major minor. Semua sama rata. Pakcik ni pegang 50%, pakcik ni pegang 50%. Betul? Wait, percentage tu saya letak untuk ajar je. Dalam exam jangan letak percentage. Okay? And this one will be approximately 99%. This one will be approximately 1%. That's why chlorination will give you a few product, but bromination will give you only majority one product. Okay? And what do we explain? How do we explain? Remember the three things? Reactivity. Which one is more reactive? Which one react faster? Which one is selective and unselective? Tiga tu. Okay? So, bagi tahu lah. Bagi tahu. So, just bagi tahu kat situ, chlorination pula. Chlorine, Cl2, is very reactive compared to Br2. Okay? Dia jauh lagi reaktif. Therefore, chlorine will react faster than Br2. Okay? And when it react faster, Cl2 ataupun chlorination reaction will be unselective. Okay? But bromination reaction will be selective. Setuju? Therefore, thus, both, yang ni kena ikut soalan lah. Both, tak nak guna both lah. Nak bagi ayat yang kamu boleh guna dalam semua exam. Thus, all products in chlorination untuk chlorination will be equivalent to each other. Will be, sorry, equivalent to each other. Tak. Will be equivalent amount. Boleh lah. Equivalent amount. Okay. Sama banyak. Okay, boleh. Alright. But, okay, however, bromination, okay, however, bromination will have major product. Dan label major product tu. Major product kamu adalah, in this case, bukan secondary. In this case adalah tertiary. Yang ni akan berubah ikut soalan. Tertiary haloalkane. Okay. Alright. Yang ni akan berubah. Yang ni depend soalan. Sebab kadang-kadang major tu secondary, betul? So yang tu kena depend soalan. Yang lain sama. So start off with the reactivity. Move on to which one will react faster or slower. Move on to the selective and unselective. And then explain the product. Boleh. Okay. Good Keyword, semua keyword kena ada. Tu je. Bila explain, keyword is the first thing that we are looking into it. Alright. In the exam, we will come across this type of question. You'll realize that my tutorial, other than soalan yang macam tanya straightforward latihan tu, itu latihan. In the exam, this will be the question. In the form of sentences, you know, dia takkan bagi direct. Dia takkan cakap, oh, compare the major product. Why bromine have major product? Why chlorine don't have? Dia takkan tanya soalan macam tu. Nampak? Okay. So whenever you have the same thing, 2-methylpropane, butane, ataupun hexane, ataupun cyclopropane, tak kisahlah. The same thing, tapi dia buat chlorination, dia buat bromination. Jawapan dia satu je. This thing. Dia takkan ada jawapan lain. Okay. When you are doing bromination to the same thing, you're doing chlorination to the same thing, soalan dia mesti tanya pasal ni. Okay. Boleh? Alright. Okay. Saturday ganti hari Rabu. Betul? Okay. Tapi line hampa teruk gila, aku jadi macam I will see. I'll update you what to do. Okay. I'll update you what to do and let me plan for a little. Okay. Let me plan first. Just a kind reminder, your assignment due Friday. Betul? 18 Friday. Yeah. Your assignment due Friday. So, I hope you are almost done. Kalau yang dah siap, boleh submit terus di Google Classroom. Okay? Make sure you correct everything that I have comment. Alright? Okay, kalau tak ada apa, I think that's it for today. I'll see you again on Saturday. Have a good day and I'll see you guys around.
Thank you.